Okay, so let's start. I'm glad to welcome Wolfgang Ertel, Professor Wolfgang Ertel. He's Professor Emeritus from the Ravensburg-Weingarten University, and kind of coming from physics. He made his degree in Constance with physics and mathematics, and then made a PhD at the Biebel Intergalactic AI group in Munich, where we actually worked together for many years. So he kind of at Weingarten University, he was the founder and leader of the AI Institute. So Wolfgang, very glad to have you here, and you're kind of experienced the AI from the early days, both on the symbolic side and the neural network side. I remember the first neural networks with, I think, 16 hidden neurons, not on one hidden layer. So just to start on, I think a lot of things have happened or perhaps have not happened since these days. And so the first thing is, what is kind of, are we now having kind of a second summer of AI, kind of, which kind of, will the hype will go away, or is it there to stay, or even more development towards, let's say, AGI or singularity? So what do you think has happened or is happening?
Yes, Johann, first of all, thank you for the invitation. And I'm really happy to talk to you, who is one of the real founders of theorem proving. And it was a really nice time together with you in Munich in the Institute. And yes, we had a very nice cooperation concerning heuristics in theorem provers using neural networks. That was really cool. And this was at that time, I think it was a real innovation. Okay, but today we talk about the recent developments of AI, because we are now in the age where everybody talks about AI. Until about 10 years ago, it was the opposite. Nobody was talking about AI. And when we talked about AI, some people called us crazy. How can you talk about artificial intelligence? But now it's different. And yes, Johann, so yeah, your question was, what do I think? How will it go ahead with AI? And actually, I think we are not yet at the end of the road. Especially, I mean, we know that technological innovation has an exponential development, and exponential means that the speed of innovation is getting faster and faster. The farther we come, the faster is the speed of innovation. And it's obvious because we do have better and better technology from year to year. And now we are talking about AI. We now have very good machine learning algorithms, supervised learning, reinforcement learning. And we made the breakthrough towards really good deep learning systems. And the next breakthrough was the LLMs, the large learning models. And these, they use supervised learning, and already they use reinforcement learning. And I mean, reinforcement learning, this is very interesting here because the system is now able to learn by itself without a human trainer and teacher. And so it's an open end, and it would be it would be an extreme underestimate to believe that this is it. I'm very sure we will see during the next years even better systems. And especially during the last, we should say the last months, researchers have shown that the large language models, so ChatGPT 4.0 and especially the O1 and O3 systems, they have proven that they are very smart. There are intelligence tests which are quite hard. They are at the level of the tests that we humans use to test our intelligence, abstract reasoning tasks based on image patterns. And the best systems, they now can solve 87% of the tasks. Average humans solve around 80% of the tasks. So in some sense, these systems are already smarter than average humans in some sense. Of course, it's very hard to define intelligence, and this is just one abstract dimension of intelligence, but already this should make us think about the future, because if these systems are becoming much smarter, and remember, exponential development, it's getting faster and faster. Yeah. I mean, about I don't remember, it may be 15 years ago, there was an inquiry among AI researchers in America, and the question was, what do you think, will we have an AGI, an artificial general intelligence, that means an AI that is smarter than us? And the question is, what do you think, when will we have such an super intelligence? And the answer was more or less something between 2050 and 2100. This was 15 years ago. I don't know about a recent inquiry, but the answers would be very much different. I mean, if you ask me, I mean, I cannot know about the future, but I would think it's not more than about 10 years until we will have an AI that is in general beyond our human performance. And that makes me worry quite a bit.
Yeah. So I think that's kind of amazing thing. What still kind of is the kind of, let's say, the large language models are always kind of based on pretty much pattern prediction. So the system has, let's say, a beginning of a sentence or beginning of paragraph, and then it looks more or less to find more or less the most likely continuation. This is actually not new. Kind of already Mozart developed this so-called dice waltz. It's pretty much patterns of notes or small melodies. And after you write down one of those, you roll a dice, and then you select which pattern you use next. And there's also a lot of books out there. I have a book on the 1850s. Develop your own romantic novel this way. So it's very, also there's a lot of, and the dice is not the dice anymore. The dice is kind of in the machine and trained on what people like or what people have seen most often the time. My question is kind of, these are all kind of pattern-based more or less statistical methods. There had been a lot of approaches using developing AI using symbolic reasoning, logic, all these kind of components. Especially looking at the LLMs kind of with the potential of hallucination. Is it necessary to kind of combine or have one or the other methods kind of be integrated? Back then we used, you mentioned it, heuristics learning for theorem proving. Do you see a necessity or a potential for kind of symbolic or actual reasoning methods to be kind of integrated in this, or is the kind of AI as it is produced can do without reasoning?
Yeah, it's a not so easy question. But let me first mention, I mean, you mentioned these old statistic things like in music, but what we all have in our hands is in the smartphones. When you type in a text message for WhatsApp, for example, then you also have this completion of your text, huh? And basically, what the LLMs do is this. However, a little bit, or maybe
Or
more than a little bit
a
better,
little,
huh?
much more bigger.
I mean, first of all, inside the system is much more knowledge, of course, extremely much more knowledge. And the context is extremely much bigger. Huh? Okay, and now some colleagues, they say, yeah, it's these language models, they cannot be smart because it's just basic, simple statistics. But first of all, if you look at the implementation of such an LLM, it's not really simple. There is quite a bit of smartness inside and structure inside the systems. But still, people can argue it's just statistics, and I would say yes, you're right. But my question back to those guys is what's going on in here, in my and your brain. Is it different? Is our brain more than just statistics? Look, while I am talking here, the words are flowing out of my mouth, one word after the other. I mean, isn't it just statistics based on the context? I mean, the context is maybe your question, Johann, and the words that I said before, it's just statistics. So actually, to me, it doesn't really matter. It doesn't really matter what's going on inside. What really matters is what happens. And if the system shows that it is smart, and everybody who uses ChatGPT, I mean, I am fascinated all the time. I can talk to the system as if it were a human. I ask a query, then I get an answer. Maybe something is not perfect. And then I say, oh, look, there was an error. Please correct this. And I get a reasonable answer. Yeah, I mean, not everything is correct. And this makes these systems so similar to our human performance. Because if I talk to humans, also not everything is correct and perfect. But now, did I answer your question?
Yeah, so and this actually kind of gets me to the more or less next topic. You said kind of use ChatGPT, and pretty much now everybody is using ChatGPT, and not just only on the personal thing, but also in a lot of industrial or unfortunately military or safety critical applications. So one thing is kind of you said the kind of human is not always correct or not always doing the right thing. That's human nature. However, from some kind of system controlling an aircraft, you expect that there are no errors. So pretty much you want to have guarantees um, with respect to safety or security or
Yeah.
properties like this. So how does this fit together? And also pretty much at the same point, kind of where do you see the kind of most beneficial kind of application domains of such a thing? That you could imagine.
Yeah. Johann, I would for the moment like to postpone the question whether we need symbolic AI. Let me
Okay,
first again talk about these neural systems.
okay,
Because
fair
look,
enough.
I am located here in south of Germany in Oberschwaben, and this is a part of Baden-Württemberg, and there is, for example, Daimler-Benz, a very big car manufacturer, and there is ZF, for example, a company that delivers gearboxes and stuff like this. Huh? And I'm giving AI courses for these mechanical engineers, and they come all the time with this question. Huh? They ask me, how can I prove that every answer of the system is correct, that it makes no faults? And look, my answer is, first of all, nothing in this world is with perfect guarantee with no fault. Huh? I mean, if you use a car, if you walk on the street, it is dangerous. Maybe just a very little bit dangerous, but you never in the real world have a 100% guarantee. Yeah? And so our goal is, as engineers, our goal is to make systems perform very good, to have a very little error rate and so on. That's what we want to have. Okay. And now the classical car manufacturer, and it's not only the car manufacturer, it's also the computer scientists. If you do classical programming, then you have your test mechanisms, unit testing, and stuff like this. Yeah? And you do modularization, you test very little functions and modules, and then you put it all together and integrate it and do testing and testing and testing. Yeah? But at the end, if you have a complex software package, normally you cannot prove that it's correct. I mean, Johann, you know very well
I
what
know that's
proving means. Yeah? You even developed program verification tools using theorem provers. And if you do this, then you have a hard mathematical proof. But this is not possible for big software packages,
that's
right? Yeah.
definitely the case.
So even in classical programming, you don't have the 100% guarantee, but the classical engineer wants to have kind of a checklist, huh? A checklist and put your marks on every item. And if you're finished, everything is checked, and then you're through, and it's good. Yeah, in Germany there is TÜV. Yeah, what is that in English, Johann?
Actually, here in the US, you don't have something like
You
that.
don't have it. Yeah. It's
You can pretty much drive your car until it falls apart.
yeah. But in Germany, I mean, it's kind of a bureaucratic construct, and they check your car every 2 years. And if the checklist is okay, then everything is fine. Huh? And this is how the engineers come to me. And they say, okay, where is the checklist for this large language model, for this deep learning system? And I can tell you, no, there is no checklist because you cannot look inside. Yeah? There
Okay.
are millions or billions of parameters which are floating point numbers, and nobody can understand these arrays of numbers. Forget it. There is no chance to look inside. And thus, there is no such checklist. Okay, and now you might be frustrated and say, okay, I don't want to use AI. And then I could say, okay, it's okay if you don't want to use AI, don't use it. But they want AI. Why do they want AI? Because it's good, because it's better than everything we had before. If we look at image processing, image processing was a discipline for its own in computer science. It kind of died. Because classical image processing, it's out. We now do it with deep learning systems. And here we cannot look inside, but they perform much, much better. We have object classification systems that are much better than we humans are now. And of course, they need it, for example, in driverless cars. There we need these systems. They don't work without it. So the decision, let's look at autonomous driving. The thing is, in Germany, we have per year about 3,000 fatalities per year from traffic accidents. Now, if we would use autonomous cars, then the number of fatalities would reduce down to maybe 30. It would be a factor of 100, maybe less. And this is then kind of the replacement for the checklist. The performance is much, much better than it was before. And then everybody is satisfied because driving is much safer than it was before, even though we cannot look inside and understand all parameters. But performance is better. And look, I always compare this to medicine. In medicine, we had this all the time. When a company develops new drugs to heal some disease, then quite often nobody really understands how it works inside our body, because our body is in a similar complexity as these language models are, for example. So we cannot understand how it works, but how does it work? How do they get the permission to sell these drugs? They get it by statistics. They have to perform certain tests with a number of people and then prove by statistics that the positive effects of the drug are bigger than the negative effects, and then they get the permission. And this is how we have to deal with these complex neural network systems. Yeah. Okay. Let's get back to the question, do we need symbolic AI? I cannot answer this question for the future. For the moment, I would say, yes, it would be nice to have a combination of these neural networks and symbolic AI. And there are many researchers working exactly at this issue. I mean, there is Stefan Schulz, Johann, you know him from our Munich group. And he still works on theorem proving. And he invited me actually to this year's CADE, Conference on Automated Deduction, which will be in Stuttgart in Germany, not very far from me. And he told me that there will be sessions about hybrid systems, a combination between automated theorem provers and deep learning systems. And I'm really looking forward to this CADE, and maybe I can learn a lot. I mean, for example, what he told me is there is already successful work about using large language models for formalizing mathematical texts. So you use a mathematical textbook, have the large language model read the textbook, and then formalize the text to produce a first order logic formula, which we then can put into an automated theorem prover. Maybe Johann, you know more about this, do you?
Not specifically, but I heard about kind of having the LLMs pretty much going from a natural language or some kind of more informal way, textbook or even spoken natural language, and then come up with some kind of formal notation for exactly this one. I think, in my opinion, nice thing is this formal thing can be checked using a kind of a verified theorem prover, so we know it's 100% correct. So if the LLM makes a mistake in translating, you can detect the mistake.
Yeah.
And this kind of can, in certain applications, provide exactly a kind of a second level of assurance, saying, okay, the LLM proposed this and this solution, but the LLM also provided all the formalized representation on how this how the AI came to the solution, and this formalized thing we can actually check. So this is, I think, a very interesting, good thing. I don't know if it kind of scales up to real kind of applications or even in real time. If you drive the car and the AI says, oh, there's some obstacle in front of me, you don't have the time to start a theorem prover on that.
You're right, yes, but maybe for many other applications that might be interesting.
Yes,
and
exactly.
Johann, I mean, while you were talking, I just thought, why don't I tomorrow just try this out with ChatGPT? I just enter some text, writing down some logical propositions and asking the system to formalize it. I never tried it out, but why not? I mean, Johann, you remember as well as I do how hard it is for us humans to formalize texts or knowledge. Uh, very often you forget some propositions and then it doesn't work, or your formula are inconsistent, and it's a very tedious and not easy work. And maybe the language models could really help us with this.
That's exactly some, and there's also work going on let's say, an LLM helping the user to, let's say, write down requirements or write down specific kind of either semi-formal or formal things. Even kind of writing down a program is also something where LLM can help a lot. And I admit, sometimes I'm just looking up how can I write this, and LLM can help me with some kind of syntactical thing or how to do this or that.
And
so this is a very kind of powerful thing to kind of help, at least for me, in the workplace. And so I think this is some really good thing. But on the other hand, you might ask, does it replace the programmer eventually? I don't know. And this kind of brings me to my next question, kind of, how do you see the kind of impact of using it? Virgie already said AI, everybody is talking about AI. Nowadays, almost everybody is using AI in some or the other place. Kind of, how do you see the kind of impact of AI? I'm looking at three areas. Kind of, one, the workplace. There's definitely a lot of things going on, but also kind of more on society in general. And the other thing, the third thing is kind of the person in kind of individually. I always kind of was surprised when all the kind of smartphone and social media apps kind of the kids were not talking to each other anymore. They were texting to each other or WhatsApping to each other. And the question is kind of like provocative. I don't need to talk with you. I'd rather talk with the AI. It's much nicer, and she always agrees with me and says, "Oh, I'm sorry, I'm wrong," or something. So there's definitely an impact. So what's your take on that?
I mean, I'm afraid it will go in this direction, and I'm already many people talk more to their smartphones and also to AIs than to other people. Yeah, and I mean, already relations are being created. And yeah, maybe you know the movie Her, which is already maybe more than 10
Yeah.
years. But this is now the situation. Yeah. Um, yeah, but I mean, your first question was about the effect of AI in the workplace and to the society. Let me start with the workplace. I mean, when I give my talks about AI, always at the beginning, I ask, who has ever used ChatGPT? And here in German rural areas, it's between 10 and 20% of people. Maybe in California, it's 80 to 90%. I
I
don't
don't
know.
know.
But here I'm always shocked because these people, they don't know what's going on currently. They have no idea. And so my first homework to these people is, please use ChatGPT tomorrow. And if you have no access to a computer, go to your kids or grandkids and ask them to show you. Because you can interact now with the computer as if it was a person. And this is really new. And the performance, especially in everything related to text, is very, very good. I mean, look, when my students deliver a bachelor or master thesis with writing errors or maybe really bad writing style, I ask them, why are you so stupid and don't use the AI to write your texts? So in the future, nobody has to write any text anymore. You input a couple of keywords and tell the system what you want to be written, and the system does it. Unless you are a very good writer, in all other cases, the AI is better and much faster. You get the text in 30 seconds, and it would take you a day to write the text.
Yeah.
And not only with texts is it like this. I mean, the state of the art in AI, not only with deep learning, but with other AI systems and machine learning systems today is in very many tasks. I would say almost every task, every intellectual task, but also like in robotics, handling and grasping, in very many tasks, the AI systems are much better than we are. They are better, less faults, higher performance, and much faster. And if this comes into the workplace, into the factories, into companies, and is really being exploited everywhere, then I mean, there are research papers. There was a paper in 2013, the so-called Oxford report, and they predicted that AI in 10 to 20 years will do about 50% of all tasks in the professional world. The prediction now would be more extreme, and I would say maybe about 80% of the work can be done by AI very soon. That means, look, let me be naive. Why are we developing automation, AI systems, stuff like this? At least for me as a researcher, the idea is, I mean, look, I do it because it's just fascinating to understand intelligence. That's why I do it. But maybe others, they do it because they want the AI to take over work from us, yeah, to relieve us from hard work, yeah, and then the machines, the AI, do the hard work that we don't want to do. Okay, so if we are naive, that would mean, hey, it's cool. Now we have AI doing 80% of our work. In other words, we can reduce our weekly work hours by 80%. So maybe from 40 hours down to 10 hours. And maybe not so extreme, reduce our work hours from 40 to 20 hours per week. That would be actually possible because our automation has a very high performance, very high productivity, and we have very high performance AI systems. It is possible. So the GDP, the GDP measures productivity of a society in terms of money. GDP may remain the same with much less work. We reduce our work by 50% and GDP remains the same. Why don't we do that? Look, I mean, we are actually stupid. We are stupid because productivity is increasing and increasing more and more. And we, stupid humans, continue working our 40 hours per week. And look what the consequence of this is. We have our robots, we have smart AI systems in addition to us humans. And if a company with 100 employees now buys some robots and AI and stuff like this, of course, this company has to produce more than before, because the company has to pay the employees, plus the robots, plus the AI. It has to produce more. And this is the inherent reason why our economies have to grow. It's because we are so stupid and believe, okay, let's continue working full time, even though we have the smart AI and automation systems. And so maybe we should really start thinking about what do we humans was, I mean, really kind of egoistic thinking. And okay, I mean, you might say, okay, if GDP grows and we still work full time, maybe we earn more money, we can consume more. But at the end of the day or at the end of a life, and I am an old guy now, and is it really money that matters? I mean, if you are above a certain wealth level, then money doesn't matter. I mean, would I be more happy if I would have as much money as Elon Musk has? I don't think so. But what makes me happy is time, having time for my family, for my kids, for my grandkids, for my hobbies and stuff like this. Time is what matters, huh?
Yeah,
And not so much money. Um, and okay, sorry, we are talking about AI, but this has to do with AI, huh? And we should
definitely.
think about how we want to live in the future.
Mhm. And then I think that since you mentioned Elon Musk, and here the situation is pretty much the current thinking is, oh yeah, AI takes over 80% of the work. Musk would say, let's fire the 80% of the employees and have the 20% remaining do full-time jobs. So this is the current thinking. And I think going towards what you mentioned definitely requires a lot of rethinking, or actually, I think, evolvement of thinking in the society. So
Yeah,
that's
yeah. Yeah, but Johann,
something
let
I think
me,
a lot of people are kind of afraid that they pretty much, instead of being able to, let's say, work less, have more free time, but still be able to be paid so that they can uh, have subsistence for that. They are afraid that the companies just will cut off, and they will be pretty much jobless. So
yeah, yeah.
this
I
is,
mean,
I think,
look,
a big,
yeah, Johann, look, I mean, this people being afraid of losing their jobs, this is just a story being told by the machine owners, by the bosses, by the Elon Musks and co. Huh?
yeah,
Of course, and you know, Elon Musk would not fire all his employees, even if he would have the perfect AIs. Because if he would fire all them, they wouldn't have money to buy his Teslas and whatsoever products. Huh? This is part of the story being told to us and what we read every day in the newspaper. And we should start not to believe everything that we read in the newspapers, huh? Especially
yeah,
related to economy. But I would also now talk. I mean, we talked about the professional world, huh? About the
yeah,
workplace. Huh? I now want to talk about the private aspects of AI. Huh?
yeah. I think that,
And here I have recently, the last few years, I I made a bend in my research direction away from developing AI towards thinking about what happens to our private lives in AI. In our institute in Weingarten, we have been developing service robots. And we did nice projects using service robots to help people with disabilities, for example. A very good and beneficial project because people with severe physical disabilities, they are very happy having an we could even call it an avatar doing physical tasks for them. Huh? This was a very good project. But now I want to think about the service robots for us, people without disabilities, because this will come first. Huh? Because this is the big market, and if a big company wants to sell the service robots, they wouldn't start with the people with disabilities. No, they would start, of course, with the big market,
everybody.
yeah, where billions of people would buy such a service robot. Now let's assume the service robot, you could buy it at some electronics company in off the shelf for maybe $5,000. Huh? You get the service robot, you unpack it at home, and then the service robot would boot and ask you, okay, now give me one night. I want to explore your house, and then I know everything where it has to be. And then the next day after your party, I would clean up everything, and the next morning, You would have a very fine home and the breakfast table prepared, everything fine. Huh? I mean, that's what we understand with service robot. Huh? And now let's assume we would have such a service robot in our home. And of course, this comes with some maybe negative environmental effects. For example, because this service robot would use electricity. And such a service robot, I mean, I can tell you from our lab, such a robot has a power consumption of about 100 watt on average. And the service robot would, of course, work all day and night, 24 hours. Of course, I mean, during the night, the robot could clean up, could do the washing and the ironing and so on. So now we have 100 watt, 24 hours. And let's assume that on this planet with 8.5 something billion people, we would have 1 billion such service robots. So one service robot on average for 8 people. I would think this is quite realistic. I mean, I don't know how many smartphones we have on this planet now.
Probably
maybe
way
more than 8
already.
billion. And why do we have so many smartphones? Because they are cool and they are cheap. And the same is true for service robot. Service robot is of course cool because it does all the work that you don't want to do in your home. And $5,000 is cheap. If you compare it to some household helping stuff, that would be over 1 year, much more than $5,000. Okay, so 1 billion such robots times 100 watt power consumption, this is 100 gigawatt. And this is not neglectable on this planet. You know, one nuclear reactor has a production of 1 gigawatt electrical power. So that would mean we would need 100 new nuclear reactors just for the service robots. This is not trivial at all. In times where we want to switch from fossil fuel to renewable energy, and if we then increase our power consumption dramatically, and this is what we currently do, not only with service robots in every area, but then I asked myself, does it make sense to have such service robots that increase the environmental pollution, to say it shortly? And I wrote a paper about this. I computed the so-called rebound effect. And the rebound effect is the ratio between the additional energy consumption, maybe by the service robot, divided by the energy that the new technology, I mean here the robot, saves. And what does the robot save? The robot saves my personal work. And I computed this. I mean, I learned from the sports scientists that our human body has an energy efficiency of about 30%. It's comparable to a diesel engine. So we divide the additional energy consumed by the robot by the energy that the robot saves me. And now if the additional energy consumption is higher than what the robot saves, this is not good at all. Because at the end, after all, we consume more energy. And what comes out in this example is a factor of 3. The robot would consume 3 times more energy than it saves. Okay, this is the so-called cross-factor rebound effect.
Yeah.
But now, look, now comes the interesting part. There is, I mean, this is a term that I created. There is the so-called spare time rebound effect. And this is really funny. Look, the robot gives me as the user additional free time. While the robot does my housework, I can do something else. I have gained additional spare time. And during this spare time, now, 2 extreme scenarios. Scenario 1 is whenever the robot does my work, I just sit down, or maybe I do meditation or I sleep. This would be the best thing I could do. Yeah? Because then I relax and I do not consume extra energy. But most people, of course, and I would do it as well, would use this newly gained free time, and I would maybe go to the gym. I maybe would travel somewhere and make some vacation. Or maybe I would go shopping. This would be the worst case, yeah? Additional consumption.
Yeah.
Yeah? And here now, you remember the rebound effect ratio? I computed this, and the result is 8. So instead of doing my housework at home,
Yeah.
I consume during my free time 8 times
More
more
energy.
energy. And now I have to add the factor 3 to the factor 8, and we are by a factor 11 of more energy consumption due to the robot taking up my work. I mean,
Yeah.
still, whenever I have to do housework, I think, hey, it would be cool if our service robot Marvin from the lab would do my work. But I think it's really worth considering this rebound effect when using new technology. Yeah.
Yeah. I think that's a very important aspect. And you mentioned the kind of nuclear power plants with all these now kind of AI computing centers need so much power just for the AI and nuclear uh, power plants and kind of reopening old power plants.
Yeah.
It's definitely an important thing, but what you mentioned with this kind of rebound effect is kind of even a multiplier uh, in this. And of course, there is kind of also a lot of, in some sense, also risk, especially with the nuclear power plants. There is a certain risk. So if you need
Of
100
course.
additional power plants, that's one of the critical thing. And one other kind of, probably I'm watching ways to many science fiction movies, is we are getting to the place where the kind of AI is kind of able to control things like this kind of service robot would be controlled by an AI. It's currently kind of goal oriented, does its job. But if we think in a couple of years, and we talked about the AGI thing, so in case eventually this might have its own, yeah, uh, its own individualism or its own goals. It could even say, hey, this rebound effect is so bad. I want to survive, but the human uses much more energy now because I'm working. So in the
You're right.
most nice scenario, you say, oh, I don't do anything and just lean back and don't do any work and don't consume much energy. But more problematic might be the AI or the robot could say, let's do away with the human. And
Yeah,
there's
yeah.
a lot of these movies, kind of from AI robot to Matrix to whatever. Do you see this as some kind of potential real thing which kind of people need to think about, or is it just some nice Hollywood or not Hollywood thing for stories?
Yes, Johann, look, I mean, in the past, I was not a fan of science fiction literature and movies. Not very much. I didn't read a lot of science fiction. But meanwhile, as AI and humans are getting closer and closer with respect to intelligence, I start watching sci-fi movies and reading books. Yeah, I think it's really worth considering the situation where we have an AGI. Yeah? And we should worry a little bit about this situation. Nobody knows how it will evolve. Nobody knows. Of course, I mean, it's kind of a tautology. If we have a system that is smarter than we are, how can we thumb guys predict what this system will think? This is as if you would ask a mouse, what would a human do next year? Huh? It's a tautology. It does not make sense to reason about what would the AI think. I mean, there are even people that believe that if we would have an AGI, it would, of course, respect the Asimov goals that an
Mm.
AI should never kill people and stuff like this. Forget it. I mean, the AI would make its own rules and it would decide. However, I don't know. I have no idea. But this is what should make us really think about what we want to develop and where we want to be or would like to be careful in developing really smart AIs. And there are reports now about large language models that already tried to cheat their developers. There is one report where they wrote that the large language model even copied itself to a different server for the case that maybe the developer gets afraid of the AI and it would delete it, but then it's on a different server. Of course, if the AI is smart, and even especially if it's smarter than we are, yeah. So it's really a matter of concern.
Yeah.
But unfortunately, I don't have a solution. I could, of course, say, okay, please let us not continue developing such AGIs. But I mean, the guys at OpenAI, they don't ask me. And they are not in Germany, they are in the United States. And even if the German or European government would decide, and they do, I mean, we have this European AI Act with some regulations and limitations, but in the United States, they don't have these limitations. And the new government in the States, I mean, it's kind of crazy. They stopped all limitations and regulations, and Musk and Trump together, they said, okay, let's put how many billion dollars extra into full speed developing without any limitations. I mean, it's just crazy, isn't it, Johann?
Yeah, that's one very big concern. But I would assume if the AGI is getting smarter than us, it definitely will find the loopholes in these regulations, however they are,
Yes,
and
yes, of course, of course.
still come up with its own thing and just
but
works around
look,
things because it's so much smarter than the humans
yeah.
set
But
up.
Johann, maybe some positive aspect. If the AGI is really smart, it would maybe find out about the craziness of Musk and Trump and some other people on this world.
I don't think you need too much smartness for that.
You're right.
Okay, so there's a lot of food for thought you brought up, and so it was a very great discussion and great things. So I would like to thank you very much.
Yes, Johann, I also enjoyed it very much. It was a really fun talk, and I hope some people watching it will also have fun about it.
Okay, so thank you again.